Hello again, this is another one-week lesson on 10.3 and 10.4. 10.3 is placing numbers on a number line where they actually belong on the number line. And 10.4 is comparing two numbers using less than, greater than, or equal to. Again, this is for 1 week. Students should watch the video, then complete the lesson in Class Kick. Again, you do not need to show work on the screen on Class Kick. It's easier to do it on paper, but then you need to type the answers into Class Kick. If you need help, please raise your hand in Class Kick, or email me, or show up during office hours. So 10.3 is placing numbers onto a number line. You're going to be given a variety of numbers. You want to change all of your numbers into decimals first. If it's a fraction, if it's a percent, if it's a square root, cube root, whatever it happens to be, change it into a decimal first. Many times making them look like money with 2 decimal places will help you out. Money is very easy for most students to put in order from least to greatest. So number lines look like this. You have your smallest numbers over to the left. So for example, like -5, you have your biggest number over to the right. Smallest number over to the left, -0.5 to 0.5, your biggest number over to the right. You might count by ones like this one does. This one counts by 0.1. This one counts by 0.2. Every number line is different, so you really got to look and see what you're working with. So our first ones are 2.5, 2.8, 2.95, and 2.82. So all that we want to do is put them where they belong in the number line. So 2.5. 2.5 is exactly halfway in between 2.4 and 2.6. Again, think of it in terms of money. 2.5, we can always add a 0 onto the end after the decimal point. So that's really like $2.50. This is like $2.40. This is like $2.60. $2.50 is exactly right in the middle of 240 and 250. We always want to label what it is with the original number, so that's where 2.5 would go. 2.8 is really like $2.80. There's already a little hash mark right here, so it's right on that line. This is where 2.8 would go. 2.95, $2.95. If you think of this as $3 and think of this as $2.80, $2.95 is in between $2.80 and $3. But right in the middle would be $2.90. So then in the middle of $2.90, $2.90 is right about here in the middle. Halfway in between $2.90 and $3 would be $2.95. So $2.95 would go right there. $2.82, $2.82. Now this is $2.80, this is $2.90. $2.85 would be right in the middle. So $2.82 is in between those two, right about there, a little bit closer to the $2.80 than the $2.85. All you're doing is placing numbers where they belong on a number line. Sometimes you're going to have repeating decimals. Again, make it look like money. 5.77, that's really a repeating, 5.7 repeating is really like 5.7. The next number after that would be a 7. So that's really like $5.77. 570 would be right here. 580 would be right here. 575 is in the middle. We want 577. So 575 is right here, which happens to be this answer right here. So I'm actually going to put this answer, 575. But 577 would be after that. 577 would be, whoops, that's not where 5, oh, that is where 575 is. 577, sorry about that. 577 would be just slightly after 575. So 577 would be right here. 5.15, $5.15 would be exactly halfway in between 5.10 and 5.20. So 5.15 would be right here. Yes, I know it's 5.15 repeating, but this is just an estimate. We're estimating that it belongs right there. 5.1, there's already a hash mark here for 5.1. And we already did the 5.75, which is right here, exactly halfway in between 570 and 580. So again, sometimes you're going to have numbers that you need to make into decimals first. Type them into the calculator. So this is really like 1.73. Yes, I'm estimating. All right, it's like $1.73. 1 1/2. That's like $1.50 or 1.5. The 1 goes in front of your decimal point. Top divided by bottom is 0.5, so that goes after the decimal point. 160% is really 1.6, or we're making it look like money, 1.60. 9/5, top divided by bottom, 9 divided by 5 is 1.8, or $1.80. The cube root of 4. It is a big long number, but I'm just going to use, because we're estimating, make it look like money, 1.58 approximately. So $1.73. Well, here's $1.60, here's $1.80, $1.70 would be right in the middle, $1.75 would be right here, so 173 on that third little dashed line, that would be where 173 goes. We want to put the original number, so that's where the square root of 3 goes. $1.50. $1.50 is exactly halfway in between $1.40 and $1.60, so that's where 1 1/2 goes. $1.60, there's already a line there, so 160% goes right in here. $1.80, there's already a hash mark there for $1.80, or 9/5. And then 158. Here's 150, here's 160, 155 would be halfway in between, so 158 would be right about here. I know I'm running out of room, so I'm just going to move it over. This is where the cube root of 4 goes. You might also put it down below the cube root of 4. Be very careful with negative numbers. Remember, negative numbers work backwards on the number line, so you just got to be a little bit careful. Negative 2 3/4 is really negative 2.75. Negative 200% is just negative 2 when you type it into the calculator. The negative square root of 7 is negative 2.64 when you type it into the calculator. Negative 21 over 10 is negative 2.1. Again, I'm going to make it look like money, so I'm going to put the 0 at the end. And the negative's cube root of 10 is negative 2.15 approximately. So make them look like decimals first, they make them look like money. Negative 2.75. Negative 2.75 is in between negative 2.6 and negative 2.8. It's negative 2.7 would be halfway in between, so negative 2.75 would be exactly halfway in between negative 2.7 and negative 2.8. So this is where negative 2.75 or negative 2 3/4 would go. Negative 2, there's already a line for it, so negative 200% goes here. Negative 2.64, negative 2.6 is right here. It's in between negative 2.6 and negative 2.8. Negative 2.7 would be right in between here. Negative 2.65 would be in between these two. So negative 2.64 approximately right there. Negative 2.1. Negative 2.1 would be in between negative 2 and negative 2.2. It is exactly halfway in between, so negative 21 over 10. And negative 2.15, again, negative 2.1 was here, negative 2.2 here, negative 2.15 would be in the middle of those two, so the negative cube root of 10 would go right there. Just be very careful with the negative numbers. Again, we're not trying to be perfect, it's just an estimate. The next part is comparing using less than, greater than, or equal to. You learned at the elementary level, remember the mouth opens towards the bigger number. So your bigger number is going to go here, your bigger number is going to go here. You want to eat the more number of M&Ms, that's how most elementary teachers do it. So the mouth opens towards the bigger number. Again, we're going to change all the numbers into decimals first. So compare the numbers from left to right after the decimal point. We have a 3 and a 3, point and point. So far they're tied. 8 versus 4. Now be careful. It's not 42 versus 8. Remember, you want the same number of decimal places, so I could technically put a 0 there. So really it's like $3.80 and $3.42. Another good strategy is to make it look like money. Or just go number by number by number. 3.8 versus 4. 8 is bigger than 4, so the mouth opens towards the bigger number. It is greater than. Or $3.80 is bigger than $3.42. 42.2 repeating and 42.2. They look like they're sort of the same, but this one is repeating. We have to go one step farther. If we add the next number here because it's repeating, that's really a 2. The next number here, because that's terminating, the next number there would be a 0. So this is really like $42.22. This is like $42.20. 22 cents is bigger, so that is greater than. Or go number by number. 4, they're tied. 2, they're tied. point, 2, 2, 2 versus 0. 2 is bigger than 0. 27 fifths is really 5.40 when you put it into the calculator. 5 1/4 is really 5.25 when you make it into a decimal. $5.40 is bigger than $5.25. Or 5.4 versus 2. 4 is bigger. Square root of 36 when you type it into the calculator is 6. So we have 6 and 6. 6 and 6 are equal to each other. Be careful with negatives. Negative 2.6 and negative 2.66. The more negative a number is, the farther away it is from 0 on the number line, the smaller it actually is. I'm going to actually go back to the last lesson for a second. When we take a look at a number line, oh, no, it's in 10.3. When we take a look at a number line, the more a number goes to the left, the smaller it actually is. Your smallest numbers are here, your biggest numbers are here. So keep that in mind. When we're looking at this one, the more negative a number is, the smaller it actually is. So when we're looking at this is really like negative 2.6 versus negative 2.66. The more negative a number is, the smaller it is. So negative 260 is actually bigger than negative 2.66. Because negative 2.66 on your number line, negative 2.66 would be here, negative 2.60 would be here. So the more negative a number is, the smaller it actually is. 27%. 27% is really 0.27. Well, 0.27 compared to 2.7, $2 is bigger than $0, so this is going to be less than. $2.70 bigger than 27 cents. Radical or square root of 5 and square root of 6. Square root of 5 is 2.23 approximately. Square root of 6 is 2.44 or $2.44 approximately. $2.44 is bigger, so it's less than. Square root of 3 is approximately 1.73. Now, sometimes you are going to have to go to a third decimal point. This is just an approximation. Really, on your calculator, when you type in the square root of 3, it's really 1.73. The next number is 2. So far, they're tied. The next number is really 0. Well, the number after here is really 0. The next number on your calculator is really a 5. The next number here would also be another 0. So we're really looking at this 5 and the 0. Sometimes you have to go more than just the 2 decimal places and making it look like money. You got to go until they're different. So 5 compared to 0, 5 is bigger, therefore it is greater than. A negative number is always smaller than a positive number, so this has to be less than, because a positive number is always bigger. The square root of 56 is approximately 7.48 or $7.48. The cube root of 56 is approximately $3.82. $7 is bigger, so that is greater than. The cube root of 88 is approximately 4.44. 444% is 4.44. Now you would think they might be equal, but they're not. This was really an approximation. When you type that into the calculator, the next number here is really a 7. The next number here would really be a 0. So we're really comparing the 7 versus the 0. 7 is bigger, so it would be greater than. Again, do your assignment in Class Kick. It should give you answers automatically. If you need help, raise your hand in Class Kick or email me. Thank you.